before starting any machinery, all protective guards should be in position and be secure. You do not want to disable or override any safety devices. These could include, but are not limited to, a foot pedal switch, which would indicate that an operator has to be in position in order to operate the machine, an operation presence switch that could be integrated into a seat. This could be on lots of pieces of mobile equipment, and you may even see a very simple form of this in an application such as a lawnmower. This can also be a dual hand operation device, so you wouldn't want to disable one of these, and the importance here is that this may be used in a press application where you have to have one hand in place on one control and the other hand used to operate a second control, which ensures that the operator has his or her hands free of any potential pinch points within a press operation. And this could also include a position switch or a pressure limit switch that's utilized within the system. You want to make sure that none of these safety devices that are intended for safe operation are overridden and can result in unsafe operation or potentially unintended movement of a machine or actuator. So those safety devices are in place for a purpose. You want to make sure that those are not overridden, bypassed, or removed. Another important safety guideline with respect to startup and operation is that you should monitor gauges at startup and during operation. If they are not reading the normal values, so it's important to know what the normal values are and then compare those pressure readings during the startup and operation. You want to make sure that those haven't become damaged. In the case of a pressure gauge, this may be a cracked glass, a needle that's stuck in place, or maybe one that you can't actually read the gauge. In those cases, it may be as simple as replacing that damaged or broken gauge. In other cases, however, it may be the fact that the incorrect pressure reading is due to a malfunction within the system. And at that point, corrective action may need to be taken, and that corrective action may vary based upon the system that you're working in. So it's important to recognize perhaps not only what is the faulty reading, but then further what's the cause, so that you can ensure that you're not going to continue to ignore the situation and operate at an unsafe condition. So if you're seeing pressures higher than expected, you want to find out why those pressures are reading higher than normal and make sure that it's addressed before you continue to operate, where you may have adverse concerns and additional safety items that occur because of operating at an unsafe or overpressurized condition. Another guideline is fluid spillage. You want to clean up leakage immediately to avoid slippage or fire potential. You do not want to return any of that spillage to the reservoir. In doing so, this could cause contamination being put back into the system, which could then cause additional problems, both potentially safety problems, but then also performance problems by putting that contamination fluid back into the system. You want to make sure that you put any mopped spillage and any associated materials, such as oil-soaked rags, saturated stay-dry material, etc. Make sure those are all put into the proper disposal containers. You'll need to check with the employer and with local guidelines to ensure that the proper disposal procedure is followed for each of those materials. Example is that you may have a used oil container to deposit the oil that was collected or mopped up. Then an oil saturated rag may have to go into a specialty container. That may be a container that is a flammable container and then must then be disposed of properly in accordance with both the manufacturer, employer, and local guidelines. In some cases, saturated stay-dry material can be disposed of in an appropriate manner. Other places that may have to be picked up by a specialty waste disposal handling company to ensure that that contaminant is not then put into a landfill or other location that's not acceptable. When working with fluids, it's important to recognize that fire and explosion from conveyed fluids can occur. Most fluid power media, whether that's traditional oil, whether that is fire-resistant hydraulic fluid, it doesn't really matter which type, all of the fluids will burn under certain conditions. Even a fire-resistant fluid can burn if reached at a certain temperature and condition. As the fluid escapes from an example of a pinhole in a hose, that fluid can form a pressurized mist and fine spray that can be formed out of the hose. And if that is then exposed to some sort of ignition source, the fluid may flash or explode upon the contact with that source. An example may be a muffler or a hot exhaust pipe. It's important within design of machines to use area guards such as muffler guards or customized shielding, such as the ones shown, or specialty customized hose shields to protect the hose or tubing from exposure to the hot heat sources. It's also important then to route fluid conductors away from those heat sources in order to minimize the risk and potential for combustion. It's important to never, ever use your hand to check for leaks. You always want to use either a piece of cardboard or a piece of wood to use to look for those leak points. High pressure leaks can cause the fluid injection injury, resulting in potential amputation or death. And it's important to understand that gloves alone do not protect against a fluid injection injury. That injection can penetrate through various materials, through gloves that are not going to actually prevent that from being injected into your skin. So you never ever want to use hands when you're trying to diagnose a machine and look for potential leaks. The next couple guidelines that we're going to look at are related to hose manufacturing and hose assembly. It's important to recognize that you should never construct a hose assembly using components from different manufacturers. Use only the manufacturer recommended hose fittings and their hose. Using an unauthorized combination of hose and fitting may result in a hose failure that may cause equipment damage and or personal injury or potentially death, depending upon the severity of the situation. Hose and terminal ends are designed by the manufacturer to be compatible and to provide the correct clamp and connection between the hose and the terminal end during the crimping process. So if we look at what's shown here, the hose in either case has to have the proper connection with the terminal end, which is this piece that's identified here. Even slight variations and differences dimensionally and through the design of the components with the ferrule or the stem, even slight variations in that can cause for an insufficient crimp and connection point between the terminal end and the hose, resulting in terminal end blown off, which is what both of these examples are showing. During the hose assembly process, do not lubricate the hose cover. This is the outer layer of the hose construction, and it's important to not lubricate that location. In many cases, lubrication is required on the stem to ensure that it's inserted properly into the hose, but where you don't want to have lubrication is on the outside cover, located between the terminal end and the hose. So at the area that's shown by the arrow here, this left image is pre-crimp process. The one on the right is after the crimp process. And the idea here is that if you have oil at that location between the ferrule and the hose cover, that could also lead to the potential for terminal end blowoff. During the hose crimping process, all settings are approximate. Machine tolerances exist with each crimper die set and the supporting piece of equipment that's used. So this will all affect the actual setting. Always check the crimp diameter to ensure that it's within the published limits. Failure to heed these instructions can result in improper made assemblies, again resulting in blow off of the hose or the fitting at high pressure, and then that can also lead to the risk of fire or serious injury due to the loss of fluid. So the importance here is to recognize that the die sets and the crimper device are a set and are designed to be used with a given manufacturer hose. You want to make sure that those are correctly selected. And then in addition to making the crimp, make sure that it then falls within the specifications to make sure it meets the requirements of the hose manufacturer. Over crimping and under crimping the hose can also cause that hose assembly to fail, usually by blowing off under pressure. Always want to inspect the hose for the proper crimp specification following the crimp process, and ensure that the measurement is within the manufacturer's specification, often given by a tolerance. That may give you a specific dimensional value, either plus or minus a certain allowable tolerance window from variation from assembly to assembly. In the measurement process, this should be measured across the flats at the midpoint within the crimp and between the ridges formed by the crimping dies. So when we're talking across the flats, we're talking across the flats sections here, and then at the mid location between one end of the ferrule and then the other, and then away from the ridges, which is this point right here and here, that are created by the die sets when those are compressed against the stem and ferrule and hose assembly. Another guideline specific to hydraulic hose is to understand that the orange cover alone does not ensure that the hose is a non-conductive hose. Based on SAE standards, the SAE standard calls for the use of an orange hose as an indication for non-conductive hose type. However, some hose manufacturers produce hose in a variety of colors, including orange. It's important then to recognize that the hose ley line must list the SAE specification and the words non-conductive in order to be used in a non-conductive application. A common application of this type of hose is in the use of an aerial lift platform or boom truck that utilizes a tool work circuit such as a cutter, a crimper, a wire puller, or a small press such as an Enerpac cylinder. In those cases, a lot of times the non-conductive hose is a requirement, and it's important to then recognize it not only has to be orange, but also needs to include that specification on the ley line of the hose. The next safety guideline is related to hydraulic fluid as a whole, but it can be addressed with the proper part selection. There are many fluids that can generate static electricity, and it's important to recognize that and to ensure that it's recommended to then contact the hose manufacturer if there's any concern about the potential for electrostatic buildup and potential discharge to ensure that the hose that's used for the application is compatible and would prevent that static buildup from occurring. It's always important then to also measure threads when identifying fittings, because there are so many threads that are similar in measurement and they may look very similar just by a general look. The proliferation of threads on the world market today makes it easy to mismatch threads, resulting in a leakage and possible serious accident. It's important then, when you're looking at a given fitting and thread type, to measure as many threads as possible to ensure a proper and accurate measurement. It's important to then check the standards and the various fitting tables for the specific size and specification to ensure that you're identifying it properly. Some thread types have similar thread pitches and diameters across different types. Proper determination or identification then comes from recognizing the fitting type, such as a flare fitting, like the one that is shown, or recognizing the potential presence of a seal within the fitting, such as a face of the fitting and an O-ring face style fitting. In the case of the flare fitting shown, the flare angle must also then be measured for proper identification. In order to use the various kits that are shown, either from Eaton, Gates, Parker, or any of the fitting manufacturers, those thread identification kits are used to identify and make sure that you don't have an incorrect fitting for the application, and make sure that you don't have a set of mismatched threads that would result in a leak. It's important then to understand that there's a basic 3-step process to identify those threads, one of which is measuring as many threads as possible. The first step is to measure those threads, measure that thread pitch. The second one is then to measure the diameter of the threads. And then the third is to measure the seating angle where applicable. And again, because of the similarity in thread types, as many threads as possible when making that measurement gives the most accurate reading to ensure that you have it properly identified. The next safety guideline also relates to properly identifying fittings. However, in this case, we're going to be looking at the terminal ends for a hose assembly. Each manufacturer has its own ferrule and stem markings to match the different types of hose. This marking system can be part of a part number stamped on the product or a set of notches or lines on the part. For this reason, it's recommended to consult, again, the manufacturer for the details if you have any questions on properly identifying those fittings. With the ones shown, you can see that some may have a part number stamped on the actual ferrule to be aligned with the part number stamped on the stem, or it may be an identification such as the machined rings that are shown here by the one on the right with 4 versus one with 3, another one with 1. And the idea here is that those identifying features are specific to manufacturers to ensure that the proper terminal end parts, in this case the stem fitting and the ferrule, are properly mated and matched with the given type of hose that you're assembling. When cutting hydraulic hose, always wear safety glasses and also avoid wearing loose fitting clothing. Hearing protection is also strongly recommended, and it's important that cut resistant gloves be worn by the person cutting the hose as in shown. In this case, you wouldn't want to use a pair of latex gloves. You would want to make sure that you have proper type of glove as well during the cutting process. The cutting of any hose will generate some debris that, if not properly removed, can damage the hydraulic system. Many times, the cause of early system component failure is the result of debris left in the hose during the cutting and assembly process. What is shown here in the photograph on the right is the use of one of the cleaning plugs that are projected through the hose to clean any of that debris out of the hose prior to completing the crimping process. The next safety guideline is specific to hose testing. Water or another liquid suitable for the hose under test shall be used as the test medium. The use of air or other gaseous materials as testing media should be avoided because of the risk to the operators. In special cases where such media is required for the test, strict safety measures are imperative. Furthermore, when a liquid is used as the test medium, it's essential that all of the air is expelled from the test piece because of the risk of injury to the operator due to sudden expansion of the trapped air that would be released when a hose burst or a fitting is open. So in this case, what's shown on the left is a hose burst test. Integrated into this often is a method to be able to bleed the system of air prior to conducting the test. Air is compressible, and therefore when it's released, you can have a sudden release of energy, which can cause potential safety issue and potential injury. Whipping hose. If a pressurized hose or tube assembly blows apart, the fittings can be thrown off at high speed, and the loose hose can then flail or whip with a significant force. Where the risk exists, consider using guards or hose restraints to protect against injury. You do not want to temporarily drape a return line hose into a reservoir. Even within a return line, the hose whip can occur dependent upon the flow rate and the velocity of the fluid returning to the reservoir. Here are just shown several examples of hose whip restraints so that in the event of a hose failure, this can be prevented from the hose whipping back and forth during that sudden loss or rupture of the hose. Caution must be exercised when isolating or trapping fluid in a cylinder or a hose or a circuit, such as in the case of a tractor implement with quick disconnects. While disconnecting the quick disconnects, this does lock up the cylinder or isolate the circuit, but it subjects the actuator and any connecting lines, hose, or tube to possibly be dangerously overpressurized due to thermal expansion. Thermal expansion may increase pressure difference of about 1.12 megapascals per 1 degree C of temperature increase, or 90 psi per 1 degree Fahrenheit increase. To put this in perspective, if you look at a typical spring day here in Pennsylvania, it's not uncommon to see daily temperature swing of upwards of 35 degrees Fahrenheit. If you have a 35 degree Fahrenheit temperature increase in the day, that can increase your pressure by 3,150 psi. So if you have a system and you shut it down with 1,000 psi trapped within the system, and then have a 35 degree increase in temperature during the day, that 1,000 can now increase to 4,150. So that just kind of gives an idea of the magnitude. When testing cylinders, it's important to follow lockout, tagout procedures. Ensure that any suspended load is mechanically locked or lowered to a safe, non-pressurized position before making any adjustments to load holding valves or loosening any fittings. Shown are examples of typical lockout devices. This first one here is a dump box prop that can be put in place of like a utility dump bed to allow for that cylinder to be removed and serviced. Or you could have, in this case, a cylinder prop stand that's put in place to lock the cylinder in position to be able to then perform service on the machine and prevent that cylinder from drifting down. With counterbalance valves, It's important when reducing the pressure setting of this type of valve in order to lower a load to be certain that no person or equipment could be harmed as the load is lowered. You want to slowly adjust the valve towards the lower pressure setting and be certain that the load is always under control. The pictures in the schematic here are shown as representation. The cylinders shown are ones that contain counterbalance valves, as well as the circuit on the right. However, they are not a matching set of photograph to hydraulic circuit. It's strictly here to show representation when we're talking about a counterbalance valve, what device it is that we're looking at. When removing one cylinder from a function that uses two cylinders, again, it's important to support the load. Do not rely on the other cylinder to support the load. The load must be removed from both cylinders and mechanical locks put in place to prevent movement, similar to the ones that we showed a few slides ago. Dual cylinders are common in large mobile equipment, and shown are just some examples of different systems that utilize two cylinders to lift the load.